Well, I think we're ready to get started here. We're at the top of the hour, and I'd like to welcome everyone and thank you for joining us. This is John Crane webinar titled Cut Mill Water Consumption by More Than 75% and Improve Reliability. My name is Michael Wilder. I'm a marketing manager here at John Crane, and I'll be facilitating the webinar for today. Just to let everyone know here, you are on mute, and we will keep everybody on mute throughout the webinar today. We do, however, welcome your questions, and on the screen you should see a Q&A icon there, and you can click on that and enter in any questions that you might have throughout the webinar, so please do so throughout. We'll collect them, and then we will answer as many as we can at the end of the webinar. We're sensitive and will be sensitive to your time today, and especially the time that you afforded us. So we want to make sure that we end our session as close to the top of the hour as possible. So any questions that we're unable to respond to, we will answer them and share them with all the attendees in a follow-up email. Note that we will be sending an email also to all registered attendees, both those that are on the webinar today and those that were unable to attend, with a link to access the webinar recording. So you'll have an option to refer to this at a later date and also share with your colleagues. So please do so. So again, welcome. Get through here and do a quick commercial for John Crane. For those of you not familiar with us, John Crane is more than just one of the world's leading providers of engineered technology. With more than 6,000 employees around the globe, we supply and service the products used by our customers and process industries for their mission-critical operations, many of which involve some extremely challenging conditions as you experience in pulp and paper mills. Our outstanding reputation for designing and engineering high-quality, durable, customized solutions is globally recognized. We partner with our customers and help them meet the latest environmental standards and keep their operations safe and controlled. And we were founded more than 100 years ago and as a global leader, and we are a global leader in rotating equipment solutions, supplying those engineered technologies for many industries, many vertical industries, including the pulp and paper industry, which is obviously why we're here today. The objectives for the webinar is we really hope to provide you with practical strategies and solutions that we know to be successful at achieving your mill productivity goals, to do a number of things: increase MTBR, maximize critical pulp seal life, lower maintenance costs and downtime, improve paper equipment reliability, avoid unplanned and planned downtime, and increase pulp production capacity to higher levels. We look forward to following up with you after today's webinar, and we look forward to discussing how John Crane can help you achieve your specific productivity and water reduction goals. So let's get right into it, and allow me to introduce your speakers for today. We have, and you'll hear from him later on, Kari Leitinen. Kari is our Technical and Engineering Manager for Global User Sales and Service in the Nordic region. And he's also the Design Authority for John Crane Safematic Mechanical Seals and Support Systems. Kari has been with John Crane for over 20 years and has held multiple positions in the engineering field. And you'll hear from Kari later on today. First speaker is Adrian Conrad. Adrian's our Global Product Manager for Mechanical Seal Support Systems, covering both engineered API and ANSI DIN systems. He's responsible for the marketing strategy, supporting marketing and sales initiatives, and driving new product development. Adrian's been with John Crane for over 12 years and again has held multiple positions as an engineer in customer reliability and design, but also has been a manager of our engineering university program, which brings in recent engineering graduates and kind of puts them through an accelerated program. So we've got really two great qualified folks here to share some of the strategies with you today. And without further ado, I'll turn it over to Adrian.
Thanks, Mike. Yeah, this is Adrian Conrad with John Crane, and I appreciate everyone for joining us today on the webinar series. Today, we'll be covering and highlighting our technologies to help enhance mill operations and just how simple support systems and relatively inexpensive upgrades and conversions to existing process equipment can lead to dramatic decreases of water consumption, as well as money savings, where sites could potentially see decreases of water use in your specific plants up to and even beyond 75%. Not only would the value be sort of immediate in terms of water savings across a range of applications and a number of pumps, but by reducing and controlling water or seal water usage with properly filtered flush, it will result in an extended equipment uptime. By minimizing the excessive and sometimes sort of unnecessary amounts of water flow directed across mechanical seal faces, the rate of seal wear and seal failures will in turn keep your equipment up and running longer than maybe your current MTBR or MTBF levels. As we transition here, first we'll kick off by providing an overview of the pulp and paper manufacturing processes, the difference between the two processes, significance water plays in overall paper production, and how water usage impact and environments during the paper making process. It's important to note, specifically highlight that water is used in almost every step of both the pulp and paper manufacturing process. So where strategic implementation of water control and monitoring devices along with proper seal water filtration are key to the health of the units and overall mill operations. Here within the industry, paper manufacturing initiates within the pulp mill, where after debarking of trees are executed, these trees are turned into wood chips, introduced to the next step by being primed and then broken down in order to produce a pulp or even fiber that can be transported beyond the pulp mill, then onto the paper mill. During the process of pulping, there are three main paths or techniques to produce the pulp needed for paper making, and mostly dictated by existence of the existing site technologies and or customer needs for end product or even or the end user. All paths requiring, again, extensive amounts of water for both processing and or even cooling during the operations. The first of the processing types here, mechanical pulping, either RMP or refiner, and mechanical pulping and groundwood method. Without getting into too much detail, as many of you are aware, these methods are usually found to be cheaper in terms of production costs when compared to, say, chemical processing, where the mechanical grinding and steaming methods are used to soften the wood fibers with water lubricating equipment. As these methods are introduced into the process, implementation of our water control devices will provide water and money savings opportunity to you and to your business. The second pulp processing type, chemical pulping, that includes or incorporates chemicals or chemical introduction along with cooking at elevated pressures through either sulfide or craft method using sodium sulfide, or even a white liquor sulfite and producing byproducts, which is referred to, right, the black liquor due to the chemical integration and, again, the cooking process. During the cleaning and washing process, the byproduct or stock is then taken through a stage of bleaching to produce a required brightness of pulp using hydrogen peroxide. Also, unbleached pulp will also be used in a key byproduct that will be dried, pressed for further processing depending on the end user paper product needs. The third and last processing type is a subset of the mechanical manufacturing, which we just previously covered and mentioned. It's categorized here as a modified pulping method. Thermochemical pulping and chemothermal mechanical pulping both here require extensive amounts of water, again, and steam for softening the wood chips to produce a pulp that will be best suited for product requiring stronger paper or fiber properties. All pulp manufacturing processes result in a range of different fiber makeups, as well as paper strength through different levels of energy consumption and cost. Paper mill, here once the pulp is processed, dried, and even potentially even cut, the next phase is delivery to the paper mill for final end product production. As there's multiple pulp manufacturing processes, there are usually here the two main types of paper mills. Both mills could potentially produce a similar end product though. First, the non-integrated mill. If we go back, yep, is a fully independent, we go back to the previous slide, there we go. Additional amounts of filtered clean water is required for rehydration of the transferred pulp for additional processing to the final product. This here highlighting sort of the importance of properly filtered water, which will result in a higher quality of paper and product. Through either process, producing paper products for all types of ranging from standard printing paper to specialty paper to sanitary products. So what significance does water play in overall production? As here previously mentioned, water usage is key and also necessary in the end-to-end production of paper products. And with growing demand of paper and packaging due to online retailing and delivery within sort of the current environment and current world, mills will be pressed sort of full capacity, resulting in even more pull on the clean and recycled water resources. Equipment cleaning along with cooling systems, rehydration, in addition to steam generation requirements, will be even more vital to make the simple yet effective changes and upgrades to maximize machine and pump life. And with approximately 200 to 300 pumps potentially located within a single pulp or paper mill or even more, these targeted upgrades of the water flow control devices can quickly add up to the substantial cost savings opportunity. Even with the extensive measures taken within the paper making industry with treatment to recycling of water, the introduction of fresh water within the mills is still extremely important, still necessary, and it's estimated with about over 60 million liters of fresh water needed per day for pulp mill operations. With those needs, we can see why it's obviously critically important to minimize unnecessary amounts of seal water usage across operations and across specifically the mechanical seal faces found across your facilities. As you can see, it's estimated that between approximately 7,000 to 17,000 gallons of water is needed to produce approximately just 1 ton of paper, and with over 400 million tons produced annually across the world, that definitely adds up. In result, potentially massive amounts of unnecessary amounts of water that can be saved, redirected into back into the environment when or while never reaching the pulp or paper mill, all while saving operational cost to you and again to your business. So a few reasons highlighted for our high water usage, important to cover here, that could result also in sort of an equipment downtime. So we look so what contributes to maybe some of the causes of the high water usage. There are multiple practices and or product selection or even lack of proper product selection, which results in high water use and equipment downtime. As it is, again, necessary to use a seal water flush to maintain optimal operating efficiency and runtime for pumps or mixers. The flow amounts often witnessed within the mills are simply just too high. As external steel flush or Plan 32, for example, when control monitoring devices are not properly installed, or in a phase or in a place to consume excess amounts of water. It can quickly add up sort of during the daily, weekly, yearly consumptions there. This lack of devices prove difficult for mill personnel to even properly identify flow rates, therefore tend to err on the side of caution and flush more than required to lower temperatures due to seal face heat generation. Reasons are, points here to cover for high water usage and equipment downtime. Again, other poor water quality is another reason for elevated seal water flow rates, along with causing damage to the mechanical seal faces, resulting in equipment downtime. We see plenty of times where increased seal water flow rates are established with the idea that it will prevent clogging within the seal cavity, but instead just introduces higher rates of particulate onto the seal faces, driving down the MTBR, all while again costing the mill money on repairs, replacement, and all the associated costs when using fresh and recycled seal water. Here, by highlighting reasons and drivers for the high water usage across mill operations and the negative consequences to using the poor quality seal water, we hear it, John Crane, we have an established and definitely proven range of flow control and filtration products, along with technical engineering expertise that will help guide and improve both your pulp and paper mill water conservation efforts and mission critical equipment uptime goals. Here, I'll now hand it over to Kari, our technical and engineering manager, who will go into further detail covering design of our products and the benefits ranging from our Safeunit flow controls across to our smart flow technologies.
Thank you, Adrian. Welcome everyone on my behalf as well. So let's have a closer look of our products and start with Safeunit. As Adrian just explained, having poor controls for seal water usage causes use of it in unnecessary amounts. And Safeunit is the product to help with that. It's a single compact unit containing all you will need to support and monitor your sealing systems with. And first thing on reducing water use is obviously knowing how much you are using it. Only 10 you can control it efficiently. And say packings, for example, you have set the memory markers after repacking pump stuffing box, and later you notice that the flow has increased while pressure has decreased. This basically tells you that packings are leaking and need to be tightened a bit. And if the same thing happens with packings already used for a while, it tells you that it's probably a good time to change them. When using mechanical seals, it's equally important to be able to monitor and control seal water use. Safeunit provides means of extra safety for that. Flow alarm that Safeunit uses ensures that the seal will not run dry without water. And we do know that good quality water is not always available, so we have designed these products to deal with that. Same way as on water use, first you need to know, is there a problem you need to deal with? Say you are running a pump with a single quench cooled seal. You notice that it comes difficult to see the float inside of the Safeunit flow gauge. Using the cleaning plunger on it, you can clean the display without any interruptions to seal water supply or having to worry about any force flow alarms. The non-clock valves on safe units use a special shape on the valve nozzles, as you can see. They create one round shape opening that larger particles can pass through than with the traditional needle valve, and that helps prevent clogging of the valves. There are three main types on safe units available based on the application. The types are easy to remember as the last letter on the type tells you if it's for packings or Plan 32 single seals, single quench seals, or dual seals. There are plenty of options available for safe unit with flow rates ranging from 0.8 gallons per minute to 13 gallons per minute, and with pressure up to 360 psi to suit your application needs. The standard materials on safe units are selected to meet the industry requirements, and there are options of those on those as well for special cases. Okay, moving on to the next product. Safeunit Ultima is a heavy-duty version of Safeunit. It basically does the same as Safeunit, but goes beyond it when talking about operating limits. Safeunit Ultima has some improved features as it causes less pressure loss and has a patented check valve cleaning function. Those are useful, for example, in cases when you have a low pressure on a mill water main or need to use water that it's not the same quality as you would normally use with seals. Same way as on Safeunit, there are three main types based on the use of Safeunit Ultima. Integrated check valve is used on all types, and as it has such small pressure loss that even low pressure quench water can open it. And one good thing to remember is that although these types are designed for certain applications, it is also possible to use them on another application. For example, the SUD type designed for dual seal can replace types SUP or SUQ used with packings or single seals. And in the same way, the type SUP designed for packings can be used instead of type SUQ with the single quench seals if needed. Safeunit Ultima has also plenty of options available. The flow rates are ranging from 0.8 gallons per minute to 4 gallons per minute. Pressures can be up to 725 psi and water temperature can reach boiling point in case needed for your application. Whereas traditional means of controlling seal water on dual seals rely on measuring and manual controls, SmartFlow intelligently senses seal need for cooling and provides it only when needed. And by doing that, it reduces water use dramatically, as needed and used amount are not often the same. Based on our field experience, savings of over 90% are not uncommon with SmartFlow, even when it's been used to replace a flow meter that already saves water. Beauty of SmartFlow is that it adapts to changing operating conditions. Say you have a temporary shutdown at your mill. As SmartFlow senses heat on seal, there's no need to turn off seal water flow to save it. SmartFlow will not use seal water if seal does not need it, and it comes back online when process starts again. Also, you will not get seal failures in case no one remembers to turn on seal water flow after shutdown. And one often missed fact is that all the debris that causes problems on seals and systems is carried by the same water used on them. And when the use of water is reduced, so is the amount of debris that ends up on seals. Therefore, SmartFlow can help you dealing with less optimal water quality as well. The main component on SmartFlow system is the heat actuated flow control valve that you can see on the picture. Depending on the dual seal type, there are several models available for standard cartridge seals and fitted OEM equipment specific seals as well. All SmartFlow types can be used up to pressures of 232 psi. The temperature limit is only because of water cooling capability. Water at higher temperatures than the limit will not harm SmartFlow in any way, but to prevent the seal from overheating, it will stay continuously open. For example, if for some reason the water temperature in the mill main line temporarily increases and water entering SmartFlow is above the 113 Fahrenheit limit, SmartFlow keeps flushing water through the seal until temperature goes down, and then it starts to open periodically again. And all this happens automatically, so user does not need to do any adjustments to the system. Filters like SafeJet are essential parts of seal water systems. As we have already learned, poor quality water can cause several problems for seals and water controlling systems. We do not want impurities on water to be carried to seals, and we do not want those impurities to cause clogging on the seal water systems either. And less is more when it comes to seal water quality. Less good quality water can ensure trouble-free operation for seals much better than running vast amounts of poor quality water through them. SafeJet is installed directly to pipeline between raw water and line and seals. It ensures supply of good quality water without any interruptions. And obviously keeping filter itself clean is essential on this, and to help with water savings, SafeJet uses only small amount of raw water to flush the laminar filter periodically. And there's also a pressure difference switch to detect abnormal situations when extra flushing for filter elements is required. There are several sizes of SafeJets available to fit the needs of different size plants. And regardless of flow rate, SafeJet only uses causes minor pressure losses, so there's no need to raise the pressure on mill water main because of that. Okay, and let's have Adrian to continue with more information about the expected savings these products will create.
Thanks, Kari. As you can see here on the slide, and if we use the Safeunit in particular, the SFD model for dual seal arrangements, which Kari just highlighted for water and cost savings example and estimates, we're able to clearly see sort of the drastic reduction of mill water consumption by installing the Safeunits across here, for example, a mill of 150 pumps. Going from the conventional ball valve control or flow control setup found quite commonly across plants, and even most likely within maybe your current setups within the operations today. We see an approximate flush of about 10 liters per minute directed towards the seal faces, and oftentimes the seal packing. In either case, an upgrade and an install of the Safeunit flow control product shows a substantial savings of water and cost outlined here, and broken down with the overall savings here sort of over a course of a year. So contracting here, the differences between packing and double seal savings. We go to the next slide and targeting smart flow technology. Again, what Kari highlighted previously on a few slides ago. Here we have a similar and quite impactful water and cost saving sample with plant integration of our smart flow technology. Due to the automated and smart sensing system design to control the necessary flows across the seal faces, we clearly see that difference and potential in moving from a ball valve control and upgrading to the smart flow memory alloy technology. This resulting in a fraction of what you're likely consuming present day. This here can easily reduce water consumption well over 90%. And combined with other possible sort of Safeunit upgrades targeted throughout your site, definitely would be on your way of cutting mill water consumption by that 75% mark. Lastly, this here is definitely a great illustration to close out this portion of the webinar, and that being an actual case study summary of a paper mill making their recommended changes to flow control upgrades. One of Southeast Asia's largest paper mills, they determined sort of seal water usage accounted for approximately 40% of total water consumption within its processes, and needed sort of an effective solution to save money, but also become a reputable environmental manufacturing facility within their region. By teaming with John Crane with process review and recommendations, the next step there was implementing over actually 1,100 Safeunits models ranging from the SFP to the Q to the D Safeunits throughout their sites, within the support of, or with the support of our experienced service technicians. The results were quite obvious. Following the upgrades, mill operations reported 76% cut in still water consumption and ROI targeted within 5 years, while simplifying the overall makeup of water control and monitoring systems, making life easier with the mill operations personnel. Again, this is a great real-world example of how these simple yet effective upgrades can have a positive effect on mill operations and overall success of their business, while making again those positive strides in water conservation tied to the environment. To find out more about this particular case study and customer needs and successes here, along with other featured case studies, you can visit sort of the case study tab located at johncrane.com.
So I guess I'll take over from here. Thank you, Adrian. Thank you, Kari. So hopefully today, at least over the course of this last half hour, you've had an opportunity to understand and see a little bit about what John Crane has to offer in terms of solutions that might help you decrease your wastewater in your pulp and paper mills. Before we kind of go over and turn over to answer some of the questions, I'll give a little bit of time for Adrian and Kari to take a look at what's there. Just going to go over a couple of things that were covered today. So our solutions, John Crane solutions, our seal support systems will help you control and monitor seal water flow and pressure, reduce and predetermines the maximum seal water consumption, will help reduce water consumption when cooling fluid is required. It will help, our solutions will help predict seal and packing failures, help you reduce your maintenance expenses, which obviously then will help improve your mill's bottom line, and also achieve longer service life cycle, longer uptime for your equipment, and longer life for your equipment overall, more reliability and a trouble-free operation. So with that said, I want to thank everybody for attending today's webinar. As Adrian mentioned, there is a lot of information that's available on the John Crane website, and you can take a look at some of the material that's there, and more than happy to follow up with you as well if you have specific questions around your needs, your specific needs, or your specific goals that you need to achieve. And with that, I think we can turn it over. I can turn it over to Adrian and or Kari to answer some of the questions that may be posed.
Yeah, thanks, Mike. I'll start. One of the questions came through earlier, sort of around what's the most sort of prevalent types of mechanical seal damage found across whether the pulp or paper mills, and most commonly, I guess on both ends of the spectrum there, we see either dry running of the mechanical seal faces, so the lack of flush directly across the seal faces, just sort of the unknowns of that flow coming across the seal faces. So with those flow control sort of upgrades, safe units, integrated into the system, a good visual check and know-how of that flow properly being directed across the seal faces. And then the other end, sort of excessive amounts of maybe dirty particulate or particulate found within the seal water coming across the seal faces at a higher clip than and maybe what would be recommended, where we see the wear and tear across the seal faces, where it's limiting the lifetime of the mechanical seals incorporated within the pumps found within the mills.
Okay, thanks, Adrian. Are there other questions there? Kari, is there anything that?
Yeah, there's one. I think I can answer the question about plant having majority of the seal pump seal with packings, and what would be the product to help and how it would help. I think the best option for packings would be Safeunit or Safeunit Ultima, and obviously the biggest benefit on that would be that you can monitor the condition of the packings, and by doing that prevent any dilution to process and obviously leakages as well. And one good trick that you can do with products like Safeunit and Safeunit Ultima is that you can limit the maximum amount of water that can go through the unit. So before you connect the hoses to the gland packing, you set the flow rate to, let's say, 3 liters per minute, and after that connect it to the gland packing, and by doing that, no matter what happens on the packing, no more than 3 liters per minute is going through the unit, so you can prevent the excess use.
Okay, I see another question here that was posed. Which safe unit is not susceptible to damage from freezing?
Yeah, good question. For the Safeunit model, we have a freeze-proof version available for those places that can suffer from water freezing. So that is one of the special cases I was referring earlier. So that is available.
Okay. And here's another. Are there any limitations for the particular particle sizes if we use SafeJet?
I'm not sure if it means the maximum size of, but basically it can be used directly on the raw water line. So, well, I would say that a coarse mesh filter, if you take the water from somewhere, let's say a river or something like that, it is good to have before that anyways, because the 50 microns is the filter size. So
okay, and that might be something we could follow up to understand maybe a little bit more of the specifics that
yeah, try to understand if it's for.
Okay. And then there's another one here. I don't know if you can see it or interpret it here. Is there any difference between safe flow and safe unit regarding water consumption? We have seen comparisons between versus those in ball valves, but not between each other. So you have a comparisons between the safe.
Good question. The water consumption basically is defined by the application in most cases. So you can use either one, and definitely both of them will save a lot compared to the ball valve method of controlling water flow. Safeunit Ultima has the additional benefit that as it has less pressure losses, it can sometimes help that if the pressure on the water main line is not that high, you can still use it and ensure that there is a good amount of water getting to the seals.
Okay, and I would assume then that the recommendations would be based upon whatever specific application parameters and variables that you might be encountering there. So you probably would recommend one or the other, or both in that case.
Yeah.
Go ahead.
Yeah. Yes, definitely both of them can be used on the same applications where the operating limits overlap, so to say. But it depends on the application, basically what is the better choice for the.
Okay, well, that's all the posted questions that we have here. I don't know if you guys see anything else, but I think we're right at about 1:45 to the hour. So I guess at this point, I just want to, we can close things up. If you didn't get an opportunity to ask a question, or if you feel like you still want to ask a question, feel free to follow up with us. You'll receive, as I mentioned earlier in the webinar, you'll be receiving a follow-up email from us with a link to the presentation that you can refer to, and you can go back and look, and give you an opportunity to pause and take a look at some of the products and some of the strategies that we outlined. And if you have specific questions, feel free to follow up with us from that email, and we'll be doing the same for you. So again, thank you for all participants. We appreciate your time with us today, and we look forward to following up with you again soon. Thanks again.
Thank you, everyone.